Hey, what's up? So, few days before the exam, say no, we have a bag of calculation for the right, a bag of calculation for the but no, not this type of calculation. No, not the one they attack. Alright, this type of calculation, and this we have to go do right now. So, join me, you don't know the thing go. Let's get this thing going. Morning, evening, night, anytime at all you're watching this, thank you for joining me. Thank you for joining us. Alright, so the first thing before me even start, my daughter there, you don't know she's in the background. She probably make look nice, so just bear with her. I live near to a road as well, so you don't know more time the young them I go shot past. So I just saw the thing set. You get me? But right now, we're gonna jump into some matrices principles right now because you know the exam is a couple days away and you know matrices have to come on the exam. So let's get straight into it. Alright, so a matrix is defined as a rectangle arrangement of quantities in rows and columns. A few key terms here. So a row is a horizontal arrangement, and that's left to right. So rows left to right. Columns, a vertical arrangement, and vertical up to down. Alright, and the order or size of a matrix, this is just basically the number of rows or columns that a matrix consists of. And if you're listening right here, you realize that every time I'm talking, rows always comes first. So always just keep that in mind. Rows are always supposed to come first. Alright, so if a matrix has m rows and n columns, the order or size of that is going to be a m not times n. Alright, so we don't call it a m times n, we call it a m by n. Alright, so first thing here now, stop the video, try to see if you can state the order of these matrices that are right here. Then let us continue afterwards. Alright, so you ready for me now? Alright, so let's see what I go on right now. Alright, so state the order of the matrices below. And remember, when we talk about order, we're talking about the number of rows and columns. So P, how much rows? 1 row. 2 row. How many columns? 1, 2, 3. So what's the answer right here? Pretty simple. P is a 2 by 3. Alright, so a 2 by 3. Then, as well, T, how many rows? 1, 2 rows. How many columns? 1, 2 columns. So what's the answer for T? T, 2 by 2. Alright, we're not going so bad so far. Alright, what about this one now? A. Alright, 1 row. How many columns? 1, 2, 3, 4. So this is a 1 by 4. And then the last one here, B. How many rows? 1, 2, 3 rows, 1 column. So what's the answer right here? A 3 by 1. Alright, people. So well done if you got all of those correct. If not, I hope you realize what you did wrong. Next thing that we're jumping into right now. Alright, so addition and subtraction. And again, very important for you to know the order of the matrices. So what do we say about addition or subtraction? Matrices can only be added or subtracted if them have the exact same order. So anyway at all you want to put it, the order have to be the same, the orders have to be the same, right? So once the orders are the same, then you can add or subtract them. If the orders are not the same, nothing that can go on at all. Alright, if the orders are different, then your answer is simply not possible. Alright, so let's look at this right here. If A, 2, 7, negative 6, negative 11, and always focus on your rows first. B, 4, 9, C, negative 8, 4, 3, simplify. B plus C, A plus C, 3C minus 2A. So how would we do these? So the first piece of information that we need to know here is that we need to know the orders of the different matrices that we're working with here. So the order of A is a 2 by 2. The order of B is a 2 by 1. And the order of C is a 2 by 2. Alright, and so based on that now, what would therefore be the answer of this one? B is 2 by 1, C is 2 by 2. The orders are different. Once the orders are different, the answer is pretty simple. So my answer is going to be not possible. Alright, next, A plus C. A is a 2 by 2, C is also a 2 by 2. So A plus C will also be not possible. And then we have 3C minus 2A. So for us to do this one right here, it's the same thing like your distributive law. So the 3 on the outside, you multiply everything in C by that. So 3 times 8, negative 24. And make sure you know your negatives and positives. 3 times 4, 12. 3 times 0, 0. Please don't tell me 3. 3 times 3, 9. Minus, and then from that, 2 times a, so 2 times 2, 4. 2 times 7, 14. 2 times negative 6, negative 12. 2 times negative 11, negative 22. Alright guys, so let's continue here now. So here's a practice question. Pause the video, try it. Let's see if you'll be getting the same answer as me, and hopefully you're understanding what is happening right here now. Alright, so you pause the video, you tried yours, so let us go through this now. So the first one says a half m plus 4n. M is this, so a half m simply means a half times everything here. 4n simply means 4 times everything right there. So a half m, a half times 26, what does that give to me? 13. A half times 6, 3. A half times 2, 1. And a half times 18, that is 9. So 13, 3, 1, 9. Then 4 times all of this, 4 times 0, 0, 4 times 2, 8, 4 times negative 3, negative 12, 4 times 8, 32. And so 0, 8, negative 12, 32. What do we do now? We now simply add our corresponding elements together. 13 plus 0, 3 plus 8, 1 plus negative 12, 9 plus 32. And that's our answer for that one. Over here now, if we're supposed to check back our orders, 3 by 3, 2 by 2, orders are not the same. Once our orders are not the same, then you know what our answer is already. Our answer is not possible. Alright, next, multiplication. So two matrices A and B are compatible for multiplication if and only if the first matrix has an equal number of columns as the number of rows of the second matrix. And you might be wondering, oh my god, Mr. Foster, what do you mean by that? Don't worry, but I'm going to explain that for you. Alright, so first determine the orders, check for compatibility. If compatible, multiply by using only rows of the first, only columns of the second. If not compatible, you don't know the answer is not possible. If you need to write these down, pause the video and then you can continue here. Alright, so next it says simplify. The first thing we do is to write the orders down. So I will explain exactly what everything means now. When I write the orders down, I get a 2 by 2, I have a 1 by 2. What do you realize? You realize that these middle numbers, these are the numbers that we must focus on. These middle numbers have to always be the same. In order for you to multiply, those middle numbers have to be the same. If the middle numbers are not the same, then what it therefore means is that they are not compatible for multiplication. And if they're not compatible for multiplication, then what is our answer? Pretty simple. You don't know anything already. Not possible. Alright. Next. The first thing we do as usual, check the orders. The order of this, 3 rows, 2 columns. This is also 3 rows, 2 columns. So this time we realize that we have two matrices with the exact same order. So we must be able to multiply these, don't it? So let us check it then. So remember, check the middle numbers. You realize the middle numbers are not the same, and once the middle numbers are not the same when you are multiplying matrices, what's your answer? Not possible. So not possible. Yeah, so don't look at my bad spelling. Alright. Next now, let us look at this one. So for this one here, this is a 2 row, 1 column. This is a 1 row, 2 column. Okay, that means that in this case, our numbers in the middle are the same. That means that we can indeed multiply these together. And so to multiply, we use the rows only of the first, the columns only of the second. This is the first row. Use it to multiply the first column, negative 6 times 8, negative 48. Still using the first row, which is our negative 6, we now jump to the next column right here, which is negative 1. So negative 6 times negative 1, that gives me positive 6. Alright, and look at this. First row, first column, this answer is in the first row, first column. First row, second column, this answer is in the first row, second column. So that's how we do this thing here. Alright, so next now, we'll move on to the 5 because we use the -6, which is the first row, for multiply everything over here. All columns over there. So we now move to the next row, which in this case is 5. We're going to use that now to multiply all columns over here. So 5 times 8, 40. 5 times -1, -5. Boom, we're good. We'll move on. We're not out of time for waste. We're ready for jump on to something different. Alright. So try this one for me, people. Based on those, pause the video again. Try this one. Let's see if you're now getting it. Hopefully I get the principles that you can mash up that one here. And then all you have to do is that later you just know, so you practice a couple of these well, because this have to come on the exam. If it come on the exam, you have to know how to do the thing. You see me? Alright, so you must have finished that right now. So you pause it. Alright, so you pause the video. You ready for me again? First thing, let us write our orders. 2 by 2. 2 by 2. Orders are the same. So the first thing you do, always check to see if they are compatible. Alright. So let's go now. Since they are compatible, I am going to use only the rows of the first. Only the columns of the second. Starting with the first row. So 3 and 2, which is the first row, use it to multiply the first column. 3 times -7, -21. Then the 2 times 1, 2, so -21 plus 2. Alright, that's all good right there. And as we did from before, row 1, column 1, this answer is in row 1, column 1. Still using row 1, but now to column 2. So I hope you realize that the answer for this is going to be in what? Row 1. Here is row 1, but this time over this side because it's column 2. So multiplying the row and the column, 3 times 2 times 4, sorry, that gives me 12, plus 2 times 4, that gives me 8. When I add those together, we're going to get our answer. But before we do that, let's jump on now to the next row. So we use the first row, multiply all columns. Now it's time to use our next row to multiply all columns just the same. So -2, 0 times -7, 1, then -2, 0 again times 4 and times 4. So -2 times -7, 14, plus 0 times 1, 0. Then -2 times 4, -8, plus 0 times 1, 0. That gives me -19, 20, 14, 2. And that's our answer right there, people. So I hope you enjoyed this video. Please like, share, subscribe. You see the notification bell, press the notification bell. You see the comments, fill up the comments. Let me know how you like this video. Let me know what kind of videos more you would want. The exam is a couple days away, but let's see. I have time. I probably can post a couple more for you. So you don't know the thing already. We're outside putting students first.